Well, in 10.2, we are really doing the exact same thing as 10.1 with getting exact trig values for certain angles. The only difference is we're now just doing it for tangent instead of sine and cosine, because tangent's a slightly different ratio than sine and cosine in the sense that it doesn't include the hypotenuse. A lot of times it's formulas that do the same thing end up looking a little bit different, and that's the case here, which is why we've separated this and are looking at the sum and difference formulas for tangent in a different section. Alright, so here we go. Let's say we got two angles, alpha and beta, just like we did in 10.1, and we want to find their sum and their difference. Okay, I'll show you their sum, I'll leave the difference for you to complete. It's incredibly similar. Well, here's what our formula states. If we have two angles, alpha and beta, the sum of their tangent values, the tangent value of the sum of those two angles is a better way to say it, is the sum of their tangent values divided by 1 minus the product of their tangent values. Okay, so remember before, to use the sine cosine difference formulas or sum formulas, I had to have for my two angles alpha and beta, I had to have their sine values and their cosine values for both. Here I just need to know their tangent values, and this is the first example, so we're being pretty easy on this one, and they're given. Okay, tangent of alpha is 2, so on the top I would say tangent of alpha becomes 2. Tangent of beta is 3. After that substitution, the top just says 2 plus 3. 1 minus, there's tangent of alpha again, and tangent of beta. And just like we saw previously when we used sine and cosine, we know we're ready to simplify because all the trig functions are gone. We simplify that and get 5 over 1 minus 6, which is 5 over negative 5, which is negative 1. Okay? That whole thing simplifies to negative 1. Other ones where what we're doing here is really going from the right of the equation to the left side. Okay? Notice here, obviously, alpha is 15 degrees, the two angles I'm working with. Beta is 30, and I'm using the formula that has the addition sign on the top and the subtraction sign on the bottom. That means I am using the sum formula. Okay, so I could say this equals tangent of 15 plus 30 degrees, which is the same as the tangent of 45 degrees, which is 1. Okay, so these problems are really working on identifying which is which. Okay, this is the exact opposite. So this is really the tangent of 85 degrees minus 25. Notice this is different because on the top I have the subtraction sign and on the bottom I have the addition. That's what tells me that's the tangent difference formula as opposed to the sum. That's the tangent of 60. Well, that's the square root of 3. Remember, you could get that from your unit circle by taking at 60 degrees the y coordinate divided by the x. Okay, you might have a unit circle where tangent isn't written on there. You can always find it. Okay, for that point that you found on the unit circle, y divided by x will give you tangent. Well, one more to go here. Looks like this is going to be a tangent sum formula. I'm going to add the tangent of pi over 4 plus theta, and all I know about theta is that its tangent value is a fourth. So first of all, let's get this all written out with the tangent sum formula using pi over 2 and theta. Okay, I'm thinking of pi over 4 as being alpha and theta as being beta, if you want to relate it back to the terms we have on our formula sheet. This would then say tangent of pi over 4 plus tangent of theta, but remember it tells me right off the bat tangent of theta is a fourth, so I can just go ahead and plug that in. Over 1 minus the tangent of pi over 4 times the tangent of beta, which again is a fourth. Okay? Pi over 4 is a key point on the unit circle. Tangent at pi over 4 is actually 1. So I will substitute 1 in for tangent of pi over 4, and that leaves me with, let's see here, 1 minus, with an expression that looks just like that. Okay, all I did there is substituted 1 in for tangent of pi over 4. Top becomes 5 over 4. The denominator becomes 3 over 4. Of course, we have no interest in trying to divide fractions. Instead, we'll multiply by the reciprocal. 4's cancel. That whole expression simplifies to 5 over 3. Okay? Again, the same idea. We're increasing the number of angles that we can get exact tangent values for. The only difference in this lesson is we looked at just tangent, because the formulas to do this for tangent are a little bit different than they are for sine and cosine. So we just separated them to keep them organized. Okay? We'll call it quits there. If you have any questions, please bring those up in class and we will talk more.